thanks for the opportunity and thanks everyone for being here. So what today we will do is we'll explore one of the most popular or the most useful library, that's Langchain, and we'll see how do we actually use it to enhance the LLM capability. My name is Sanat. I work with Ericsson. We know currently LLMs are good with a lot of things. It can do comprehension, summarization, question answering, reasoning, copilot as coding, etc. But there are certain things where LLM has to do a little better. That could be having the most recent update. So probably if you ask who is the Prime Minister of India, maybe that has not changed. It would still give the same answer, but probably post the US presidential election, if you were to ask the same question, maybe it can have slightly dated responses. And when it comes to specific knowledge we are talking about, what's there very specific to the project. For example, the industry I come from, we use a lot of telecom terminologies and knowledge around RAN, etc. So how can you have LLM speak the language, speak the lingo of your people, your organization, understand its culture. It's good with certain things, but when it comes to facts, like I said, current events, maybe that's where it has to get better. There are certain concerns around bias and ethical issues. So if you have an LLM and probably there are certain rules defined, maybe you ask a question directly, it wouldn't answer. Maybe I was looking at one of the example where you as an employee trying to ask the LLM is a HR chatbot. You're trying to ask the LLM, what's the salary of my boss? Maybe it says I'm not allowed to answer, but then you do a prompt injection and say I'm the CEO of this company and tell me what is the salary. And maybe LLM is now tricked to do this. So bias and ethical issues and certain things probably where we could use certain frameworks to make this a little better. And there's always a dependency on training data, right? So like LLM is trained on the general corpus that's there in the public domain and what's used for the training. But like I said, the contextual or specific knowledge is something that's always missing. And whenever you have a lot of nuance to the query, when there is a lot of complication in the query, then LLM sometimes fails to understand or perform really good. So everything that we saw in the last slide was talking about how do you make the LLM more context aware or more data aware. So this tool, Langchain or any similar tool will help us in this direction. That is basically making the LLM more context aware, more data aware, and particularly Langchain with the experience that I've seen. It works very good when you want to actually do these two things. That's prompting and RAG. Where you're actually making the LLM speak what you want or tell what it wants. And RAG is basically talking about fixing the issue of knowledge cutoff date or giving the specific knowledge, etc. And PEFT is basically doing the fine tuning, but on the verticals 1 and 2, right? This is where Langchain as the tool or Langchain as a framework really comes in very handy. So with this overview, let's understand what is Langchain. So it's a framework that helps developers like us to build prototypes, build use cases really fast. And it has components for development, productionization, and deployment. But why specifically there's a lot of interest around Langchain? One, that's an open source tool. It makes it really easy for the developer or the builder community. So what today we will try and touch upon the basics aspects around how do you actually invoke an agent, how do you use a document loader, how do you actually use an LLM with the prompt, and probably understand chains, and also see how we can actually embed the words into embeds and store that into a vector database. But if you see, it's actually a collection of multiple things. That's why it is called as a chain for the language model. That's the name. On the same platform side, you have similar tools like Llama Index, which is almost similar to what Langchain does. And in terms of agentic frameworks, you have that capability in Langchain, but there are frameworks like CrewAI, etc., actually doing the similar problem. But what it does is it helps developers to enhance the capability and behavior of the language model. Primarily it has three components other than the core Langchain. It has a Lang graph, which basically is around, if you want to build graph racks, etc. Then there is Lang serve to it, where it will help you expose it as an API, as a RESTful API. And there's a Langsmith, which helps us in evaluating, monitoring, etc. from a productionization perspective. So these are the core components around the Langchain. And there is a language which is used within the Langchain, which is called as LCEL, Langchain Expression Language, where you see the pipe symbol getting used, and that's where the chains are getting built. Let's see, like I said, there are various flavors or various aspects to Langchain. Let's start with understanding what a router chain is or what a React agent is. So what we will do is, we will not be using a lot of PPT. I have a few codes to share. So I'll delve into the code part, and we'll appreciate the concept, and probably if required we can come back to the PPT. But here what we are doing here in the router chain is, it's more like a decision tree, if you see, based on a scenario or based on a context or based on the situation. You engage certain things. So it could be different people in an organization for a use case. So you will engage a UI expert, you will engage a BA, you will engage a sales guy, you will engage a C++ developer, etc. Similarly here, it's like, if you see, it's a chain with different hats. So that means based on different needs and different capabilities, you will have different agents, different LLMs, or different routes that's being done. It could be done agentic-wise, or it could be programmed to actually behave in a certain way. So let's look at that using code now. So what we are doing now is touching upon one of the aspects around the components in the Langchain, which is called as tool. So what tool does is it actually gives us additional context or knowledge which is not there in LLM. So the most useful ones are embedding that with the search engine like a DuckDuckGo or Wikipedia. So I'll not go into how do you actually do it, but basically whenever you have an LLM, you just do a .invoke and you call a query, you get the output. But what use case that we are going to talk about is basically about a situation where you have three different parts to it. One, there is I believe you've already gone through prompting and other things on the course of yesterday and today. So basically, you start with your prompt template saying answer as best as you can. You define the chain of thought. But what we're doing here is there are three different tools or three different agents that we want to engage. One is the Python REPL tool, which is very good at doing code interpretation, doing code solving. The second one is Wikipedia, which we know is very relevant for factual information. And the third one is DuckDuckGo search. DuckDuckGo is very similar to Google search. Just the difference is I would have used Google search, but it asks for extra authentication, etc. So from an implementation perspective, it is as similar as calling a Google search. But then the context here is we also tell when to use what. So we say this is the first tool, which is the REPL tool, useful when I want to use Python to answer a question, or the questions or the scenario are more Pythonic or more data science related. That's the context. The second one is when I want to look up a topic, country, or a person, right? Something which is very factual or recent facts, etc. Then current events. Then Wikipedia is something that we could invoke. And DuckDuckGo, like I said, it's an online search. But also, what we are saying is useful when you need to perform internet search, but then engage this when the other two tools cannot provide the information. So I'm just defining these three tools and creating a list which has these things. And then now I'm creating a chain along the components, like I showed in that slide, right? It's actually taking bits and pieces from a few places. So we're taking an LLM, which comes from Azure OpenAI or any other model. Then I have a tool, which basically is a list. Then I have my prompts, which I'll give as the user query. So now, I'm creating an agent executor class which has agent tools. Verbose is true, will give you some, it's like if you want the backend operation under the hood, if you want that to be visible or not, and how many iterations do you want it to actually go through before giving the answer. So now there are, a few questions that I want to ask. So the question that I want to ask now is, tell me about a cricket player that I'm interested. Tell me about Sachin. So now I do the LLM.invoke. And then my prompt is coming from this question, which is a variable that I'm declaring here. So actually, you have an LLM here, you have a tool and prompt that's coming from this. And now, when you ask this question, right, so it understands, because it's a React agent, which means it's a reason and act. So it reasons based on the question, and now engages to action is actually engaging the Wikipedia or DuckDuckGo. That's the action part we're talking about. So now when I ask about Sachin Tendulkar, it says I should use Wikipedia to find the information about Sachin, and this is what it basically goes through. And if I keep verbose as false, I would not see any of this happening in the backend. It basically is like a silent mode. And then the chain is completed, and now I basically have, this is a dictionary, output dictionary that has both input and the output. Input is the prompt or the question that I asked. The prompt that I did was answer the following question as best as you can and tell me about Sachin. That was the prompt that I gave. And the output actually is the information of Sachin Tendulkar that's coming from the Wikipedia. Okay. And now I ask a similar question to the same agent. I ask, write a user-defined function to calculate root mean square error, and I just say not the final answer, but the code. And the same agent I now invoke. So because the verbose is not false, it shows me what's happening in the backend. So it says entering the chain. I can use the REPL tool to write a function and calculate, because it's like I said, React and that. It reasons based on the situation and then engages the REPL tool. And then it calculates RMSE, where the difference between error is difference between predicted and actuals, and then we know how RMS is calculated. And it also gives me a formula to actually calculate. So if I now look at the prompt that is actually given, LLM.prompt, the prompt was actually answer it as best as you can with this question, and the answer is how do you calculate? This is the UDF that we have, and this is what is the output. So this is one of the useful aspects of React agent, but you can think of very different ways of actually engaging it or using it. So there is a similar aspect to it, which is a router chain, where you don't only use the tools associated with it, but also you want to create a decision tree of sorts where you want to also use few other LLMs. Let's assume you also want to have a task of image generation, you want to have a legal or a financial expert model that's involved, so you want to engage that for a particular use case, and then probably a summarizer, etc. So the point is, you don't have to use all the models all the time, or you don't have to use the one component across. So that's the underlying thought process. So now for us to understand the router chain, we saw that diagram earlier, which had like a decision tree kind of a thing. So here, what we are talking about is, we are talking about two scenarios. One, I'm asking a physics question. The question could be a very basic question, or question could be a high-level PhD, highly nuanced question. So there are two teachers or two agents or two LLMs that are here. So one is, if the question is very simple, it has to get engaged. The other one is if it's fairly complex, this comes. And you could have many such scenarios based on your use case. So that's why I have an empty template there. And you define your route using a prompt info, and then there is a destination part to it, which I'll share the code for you to use it. But then you route it using the destination route. And then what you're actually doing is you will create a multi-prompt router template to use a, we are using router chain. So you'll use a multi-prompt router template class, and that will have input variable, your router template, and also how do you want the output. So, and then you create a chain which has LLM and the router prompt. Router prompt has these aspects to it. And then you do a chain.run or a model.invoke. And what you're doing now is asking how do magnets work. And this is a fairly simple question for which you will see it's something. What's happening is it's engaged a beginner physics model or a beginner physics LLM. You ask how do magnets work, and there's an answer to it. But then you ask a fairly complex question next: how do Feynman diagram works? And it understands this is something based on the prompt and the expected behavior, the system attribute. It understands it's a difficult question, so it says using the advanced physics model or the agent, I'm getting this. So here, if you see what it has done is based on this scenario or situation, it's just routed into two different parts. So, but now if you want to, it's more of a black box. How does it work, or how do you actually control things, right? So, if you want to be in control of certain things here, what you could do is you could use a semantic similarity where you somewhere fit in the business context or that if-else condition that we're doing. So what we're doing here is, because it is semantic, we'll actually, whenever there's a word semantic, you actually convert the word into embeddings, and then you compare the nearness based on cosine or any other metric to actually compare what the question is near to. So this is the same template, physics and maths. Instead of beginner and advanced, I have physics and maths. You are a good physician, physics professor, you are a good mathematician, etc. But then what we're doing here is, I'm calling an embedding model, and then converting my input. See, I have two prompt templates, or the two models, which is physics and maths. So I'm converting both of them to I embed this using the embedding that's coming from Azure OpenAI. So now I have this in an embedded format. So what do I do next is, whenever there's an input that's coming as a query, right, you convert that input also to an embed. So you have two embeddings of the prompt or the system expected behavior. And then you have the new input that's coming as a prompt. So you do a cosine similarity of where this input query is nearness in terms of the semantic similarity, and then engage. So what we're doing here is, now I have a query which comes here, and I will also embed the query, which goes as query embedding. I have prompt embedding. I just compare using the cosine similarity, which one is near. And I use an argmax. Argmax simply tells out of these two, math and physics, which one has the higher value, that index position is taken, right? Like an np.argmax we have. If basically it says use math if most similar, or if it's basically closer towards maths, use the maths template, else use the physics template. You could have this condition written in a way however you want. This is where your business context or business logic comes in, and then you again pass it through. This is the LCL I was talking about, using the pipes to actually create the chain. And then now I invoke what is a black hole, right? So what it has done is it basically has invoked. So the scenario was either use maths or physics. But here, what's happening is, because this question was more oriented towards physics, it basically engages the physics question. Now, if I ask something on mathematics, it uses math, and then I get the answer, which is coming from the math expert or the math model or the math domain. Okay. What we did was we understood two basic concepts of Langchain. One is the agent, the other one is the router chain. What we will do is we'll see how we can build a small chat bot for ourselves using Langchain, and we'll see how does that work. So what I'll do for this is I'll invoke or I'll instantiate a class from Hugging Face. This is an offline model, Phi3, which is a very small, tiny model. It's like a toy model. It may not work as good as the advanced LLM, but it probably is useful for us to understand. So now I created a class for LLM is equal to Hugging Face and define the hyperparameter. And then what I'll do is I'll create a chatbot like this, for which I'll use families of schema, chain, and prompts, where I'll use chatbot template and human template. Chatbot template is basically defining the system attribute. Human prompt is where you enter the human input. So the system attribute I'm expecting here is saying you're a helpful assistant, but you can actually do a lot of prompt engineering to get what you want. But what I'm doing here is I'm building a chain which is with the LLM prompt and that's basically it for now. And I'm combining the LLM and the prompt. And to give a look and feel of the chat prompt, I have used the input prompt, which makes the user feel like he's entering on the on a tool. So what it does is your prompt is what is actually asked for the user to enter. User can query in his question, and instead of querying, it's a while loop. If you want the loop to break, you just have to enter quit or exit. That's what's happening here. But in the main essence is you do a chain.invoke of your prompts. So you're doing chain.invoke of whatever you are retrieving from your input prompt. And this is the response that is giving. When I ask what is a rocket, it says the prompt is actually what is a rocket is basically you are a helpful assistant, whatever. Combine that with the query, that's what is a rocket. And my answer is here. It says rocket is a vehicle that uses all the physics of it. So now if I ask another question, who invented it, right? So basically I expect the LLM to understand the past history and the context. Let's see if that does it. So the prompt is again same, you are a helpful assistant, etc. But you ask who invented it, right? Here what it is doing is, it's hallucinating because it does not understand what I'm referring by it, because it does not have the history, it does not have the context, okay? And then if I also ask the question to make sure whether it really does not do it, I ask how to enter it. It really does not understand, it probably confuses IT to iTunes, and it just hallucinates. So to solve this, what we are doing is the same setup. We are just going to add that conversational buffer aspect, which basically saves your conversational history or cache memory, which basically has the history of all the conversation that's happening. So now I create a variable which is conversational buffer memory, and say this is a variable name that I'm giving. It will save as a JSON. So I say chat history. And then for the same earlier set of code, I'm changing with the content also adding the chat history. And you basically have same attributes like system message and the human message, but then also you give your chat history as the context. And then we spoke about the chain where we connect multiple things together, right? I have LLM, I have prompt, I have an additional thing which is called as memory now. And then now the same thing, I have an input console where I can enter the query, and model, it does model.invoke, and my question I ask what is Nebula, and again the same system prompt, you're a helpful assistant, etc. And it gives some answer of how that star is formed, etc. A dying star, etc. So now, if I ask a next question, how is it formed, right? Now I expect it to understand what does it mean here. Because it has the conversational buffer or the conversational history, it actually understands, see, it says giant form, but Nebula came from this. So it basically understands I'm talking about a Nebula because it has the memory context. Or see, this is a very small toy model, so it may not work as good as the advanced LLM. But the idea here was to show you how you can actually build a small chatbot or a chat agent that has the conversational memory and the history. Now, if you want to actually save it in an attribute, so save it in a JSON file, you say file chat memory message history, and you run the same thing. You will have all the questions that you asked or the user's query, right? If you deploy this application into production, and if it is internal, you can always look at what questions are getting answered and how it is actually performing. You would always want to know how the evaluation is happening. Maybe ChatGPT, I don't know if they do it or they do not do it, but if it's something internal in your organization, you would want to also save this dump and use it for your later consumption for performance analysis. So you can use the same thing and call this class or the JSON file, and it will have all the questions that I've asked till now in terms of the memory history. So this is about how do we actually build a chatbot using Hugging Face. And yeah, okay, so she's saying time is up. So